Okay, hello, everybody. How's everybody doing here today? Good. Excellent. Excellent to see everybody here once again for the stream, for once again another class. Hopefully we'll get this one in the books. We only got through one example of hyperbolas last time, so I plan to do a couple more here for sure today, as we're going to hopefully finish up here the latter half of this next section. So that's what we have here. Chase, what news do you have to share about the chess club there, my dude? I hope you got enough members, which I think you would. Can I separate the homework into units again? It's a bit confusing now that it's all one assignment. Um, if I were to split it into units, that means that I'd have to split up the due dates. They're kind of each their own independent assignment. I believe that's how that works. I don't want to split up all the due dates because then, of course, that defeats the purpose of leaving them open until the end of the semester. And obviously, I don't want to disenfranchise you there, Sarah, to be fair. Dean will make a personal announcement of the club and send invites to everyone on campus. Also, just because. But when is the final exam test open? Yeah, I'm gonna be opening that soon. Yeah, let me answer that question there for you, Chase. Yeah, as soon as we're done with chapter 7, I'm gonna open up the final exam here. So basically, we're gonna end section 7.2 today, and then next week we're gonna finish up here with section 7.3. That's the plan here, and then I'll open it up once I finish off chapter 7, and then that'll be open and ready for you to go ahead and take. So, full disclosure there, that's pretty much how I plan on doing things. Anybody have any other questions before we get going? Again, feel free to ask or whatever you like. So, Chase, you've been doing, if you've been putting in the work and the time and the effort, well, don't need to feel nervous, I promise you. So, I gave you plenty of time, plenty of chances, so you should have plenty of time, again, with plenty of time and plenty of chances to again correct some of the mistakes, then hopefully you'll get the grade that you want there. How have I been? I've been doing really well. It's been actually a really eventful day. It's going to be a more of eventful tomorrow, more than likely. So we'll see exactly how things will go in terms of stocks and stuff. So that's really kind of where I'm at. So today was more of up and down, but I decided to make a couple of trades there and see how that'll go. And hopefully the market will reward me a little bit tomorrow. So otherwise, it's just been chill. How about yourself there? How's everybody else doing? Could wait another couple minutes if people are okay with that, or think we should get going here. Usually people come in a little bit behind, so. I don't know if we'll have enough time to do a lot of the word problems there, so they'll probably be on the homework there. Thanks, I appreciate that, Chase. So to answer your question there, I'm not sure how much time we have for some application problems at this point, but yeah, the homework there kind of reflects, um, a couple of the applications there. So okay. Again, I like to be as transparent as possible. So again, you should have a full expectation about what to expect. So again, it doesn't catch you off guard. Hey, no problem. I'm always happy to help. So no worries, no worries. Any other questions which you guys have? And we'll be discussing a lot more here, but I just want to be as um transparent as possible. So want to be clear. Alrighty. Okay. Well, I'm not going to wait for everybody to come on in. Well, they'll come in when they do. So we'll go ahead and get started here. All right. So let's do that right now. Okay. Oh, circles inequalities. Wait, circles inequalities? Oh, you're talking about the shading there for the test, for that test? Yeah, so you have to just recognize that the equation is a circle, and then basically it'll have a radius and a center, and you have to go X amount of units starting from the center, uh, depending on what the radius is going to be. Then you have to do your dotted circle or solid circle, and then shade the region inside or outside of the circle. It works the same way. So if you go back to the video when I talked about it, yeah, it was just recognizing that you have a center, you have a radius, start from the center, go X amount of units left, right, up, and down, form the circle from that, and then see if you shade inside, outside, dotted lines, solid lines, the whole 9 yards. It works pretty much exactly the same way as it did with lines. So even though it's a nonlinear inequality, it still works the same way. You still have to do a 0-0 test. So remember, the 0-0 test planet is still the same way. There's no difference. Do a 0-0 test on the original inequality, and then follow through. So if a 0-0 is inside the circle, you would shade inside the circle. If 0-0 was if 0-0 is outside, if 0-0 is false, shade outside the circle. Just because it's not a line doesn't mean that it changes in terms of how we conduct the test. So that's why that test is very effective, because it takes it doesn't just account for lines, it accounts for every single graph that you do, regardless if it's, again, linear or nonlinear. All right, let's do this. Try this again. All right. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today we're going to actually do a few more examples here of hyperbolas. Okay, we only did one last time, but today I plan to do a couple more here. So let me go and shoot the thing here. Go. Okay, so if 0, 0 is outside, I shade outside. If 0, 0 is out, so basically it's true or false there, Planet. The 0, 0 test says you plug in 0, 0 into the original inequality. If that original inequality is true, shade the side that includes 0, 0. If it's false, you shade the side that does not include 0, 0. So it just depends if it's true or false based on when you plug in 0, 0. Right? So remember to read the rule about what the 0, 0 test says. Read that carefully about how I stated that. So there you go. All right. So let's do some more hyperbolas here. All right. And so we talked about the steps about how to graph hyperbolas. All right. We also talked about how to find the equations of those asymptotes as well. Today we're going to do a couple of more here. All right. And we're going to see exactly how we find, say, how we find equations of hyperbolas and whatnot, much in the same vein that we talked about when we first talked about ellipses. Okay, but let's go ahead and start off with a different example here from last time. So pretty much, this whole class here is going to be pretty much revolving around how we did the steps here from last time, doing the thing. So okay, let's start off with this first example here. Okay, so I'm going to modify that a bit. So what is that again? Yeah, okay, never mind. It's fine. 9. Yeah. Okay, there we go. All right. So here we got 9 times y minus 4 quantity squared minus x plus 3 quantity squared is equal to 9. Okay, so what can we do here first? What do we do here first? Let's go through the process here. We had a few steps here to go ahead and find out what the equation of a hyperbola was going to be. Okay, so the first thing that we have to do is remember that we do want it to look something akin to, again, x minus h squared over a squared minus y minus k squared over b squared equals 1. Or again, vice versa here, y minus k quantity squared over a squared minus x minus h squared, sorry, over b squared equals 1. All right. So I wanted to make it look like one of these two equations here. So what do you think I should do first in this equation here in order to make it look like one of these two guys? What do you think I should do here first? Divide everything by 9. That's correct. Okay, good. So we want 1 here on the right-hand side. So remember, step 1 here is just to go ahead and make it in, change it into standard form here. So let's go ahead and do that here. We're going to divide everything by 9. So that is absolutely spot on here. Now let's see what happens when we divide everything by 9. These 9s, they'll cancel out, so that's fine. So that leaves us with y minus 4 quantity squared. Now, for the purposes of this particular example, um, and for situations when you run into this, I'm just going to put this over 1. All right, so we're going to be using that here and momentarily. So, all right. Here we get x plus 3 quantity squared over 9. And that equals 1. Okay, that seems fair. All right, no problemo. Okay, let's now identify the center. Let's find the center of this particular hyperbola. What's the center of the hyperbola here? What's the center that we get here? What's the center of this hyperbola? Remember to check your notes from last time. Okay. Okay, that's fine, Chase. Take care of yourself then. What is the center of this hyperbola? I'll wait for you guys to tell me. Otherwise, that's fine. I can wait for a while. So I'll try and do something else while you guys. You gonna tell me no? Whoa, I got an answer here. Negative 3 comma 4. All right, that's correct. Very good. All right, negative 3 comma 4 is correct. Again, negative 3 you can get from the plus 3 here. Again, it's opposite, right? This is your h. And this is your k here. Again, always opposite of what we have here. So negative 3 comma 4 is correct. Very good. All right. Let's go to step 3 here. Let's identify here our major and minor axis here. What's our major axis here going to be? What's our major axis according to the problem? What's our major axis here? Y, that's correct. All right, and again, we know that our y-axis is our major axis because it's the letter that comes first. So that's perfectly fine. All right, and of course, by default then, our minor axis has to be the x-axis. Okay, so we're fine there so far. Now comes the most important part here. We need to find, in step 4 here, we need to find our major and minor vertices. Let's go ahead and find out what that is. So our major and minor vertices. Actually, put that over here. Okay. So we have our major axis being our y-axis and our minor axis being the x-axis. Now, before we can find our major and minor vertices, what we do need to know here specifically is we need to know exactly what A and B are. So let's look at the problem here. What's A and what's B? So what's A and what's B here according to the problem that we have here in this example? So what is A and what is B? A is 1 and B is 3. That's correct. Good. Okay. So this is going to be, remember this is 1 squared and this is 3 squared. That's right. So again, we have 1 and we have 3. All right, so again, I needed to write the 1 here because that needs to be represented as 1 squared. So 1 and 3 here respectively. So let's look at our major and minor vertices here. So again, with the y-axis being our major axis, we're going to add and subtract 1 here from the y-coordinate. So we're going to have negative 3 comma 4 minus 1 and negative 3 comma 4 plus 1. Okay, so we'll have negative 3 comma 3 and negative 3 comma 5. All right, there we go. All right, and now for the minor vertices, we have b is equal to 3. So we're going to go ahead and add 3 here to the x-axis. So negative 3 plus, or let's see, negative 3 minus 3, comma 4. And negative 3 plus 3, comma 4. Okay, so this is equal to negative 6, comma 4. And we have 0, comma 4 for this other one. Okay, so now we have our major and minor vertices here. All right, so again, as we know, the major axis is going to be the guiding force for what we're going to be doing here in terms of graphing this guy and putting it together. All right, so let's remind ourselves what we did last time here with this information. All right, so with this information here specifically, is we went ahead and made our, plotted out all our vertices on a graph. So let's do that. So we put minus 3 comma 3. And minus 3 comma 5. Okay, and here we have minus 6 comma 4. Minus 6 comma 4 is right here. And 0 comma 4, which is right here. Now remember what we're going to do with this. We're going to go ahead and draw in our imaginary box. Okay, and we're going to go ahead and see what that looks like here. So I'll just dot this in purple. Or actually, I'll put this in orange again. So I think I put it in orange last time. So keep that consistent there. All right, so there's our imaginary box with all the goodies in there. No problem. All right. Easy peasy. Remember that also what we're going to do here is we're also going to draw from the diagonals here. We'll go from one diagonal to the other. Again, we have a center here of -3, 4. So let me plot that point here. 4. This will also confirm it's the center, by the way. So just pointing that out. And we're also going to do the same thing from here. Now, as we talked about from last time here, these two pink lines that you see here represent the asymptotes of this particular hyperbola. Okay, so we have most of those things done right now. Now all we have to do is basically draw in the shape of the graph based on what we see here. And then we'll need to find the additional information after that. So if we want to get our accurate graph here, remember what we want in our general shape. For the first one, our general shape looks like this. The other one, our general shape looks like this. All right? In terms of our generic shapes for our hyperbolas. So, because of that fact, again, since we know it's going to look like this because y came first here in this problem, then we're just going to go ahead and just extend that out. This is going to be the vertex of each of our particular parabolas. That wasn't very good. All right, so there we go. We got our graph here for our hyperbola. And there you are. It works like a charm. Clap. Any questions about that so far? We're still not quite done just yet, but any questions so far about that? No? Okay. And there's fewer people here today. Maybe they're all taking their test at the last second. I don't know. Hmm. Okay. Anyway, I guess we'll have to figure that out. I guess, yeah. Because usually I have a lot more people. I think I know what I'll do next time here. So, I'll probably just make the deadline here right before class, and that way they'll be like, no, I'm not going to extend the tests. Wah, wah. I'm like, but you can stick around for class. It's a good idea. All right. In any case, we need to focus on the foci, actually. That's the next thing that we need to do. So we need to find the foci, and we also need to go ahead and find out the equations of the asymptotes for this particular problem. Yeah, why do you wait to the last minute? There's no point in doing that. You waste a lot of retakes and a lot of time doing that. So there's no point. Like, I like being the master procrastinator myself, but yeah, there's certain things you got to take a little more seriously when I give you a lot of time. And yeah, that's a thing. All right. You need to ask me that question? What question would that be? Uh, I don't mean to, but it just happens. You know what just happens? I mean, look, let's be honest with ourselves here. The quack question is the sole reason of my retake. That's the thing, guys. Like at the end of the day, you guys gotta be look. Like I said, doing things at the last moment's nice, but it doesn't really turn out all that well, to be perfectly honest. I don't set like super hard deadlines here. Outside of, I give you plenty of time of which to do things. And if you just think that it's just going to be coasting by, it doesn't work that way. So, I mean, a lot of times I give deadlines, because of the fact that, you know, it's kind of like your time to step up. But thing is, it's not stepping up for me. It's more about stepping up for yourself and kind of getting better with the work ethic sort of part. You gotta get things done, then you gotta get things done. I think you all know that it usually doesn't end very well if that's the case. But I always put retakes. So, yo, Aiken, are you gonna vote for yourself there again, buddy? How are you? Thanks for following the channel, by the way, Aiken. We're doing hyperbolas here today, Aiken. It's not as complicated as it looks, in all honesty. I'll go ahead and show you. All right, let's talk about the foci here. Just make sure, by the way, Planet Gerda, make sure you get that stuff done. Okay. After this class is over. I'll tell you what, Planet and Gerda and Anna. If I end off here a bit early, will that be okay? So that way you get a little bit more time in. I won't end it now, of course, but the thing is, I know you come in for the lecture here, but if I end off here a little bit early and then we start up section 7.3 like next time, would that be preferable for you guys? Okay. So here's what I'm going to do. I'm going to show you this example, and we're going to finish off here with the foci and the asymptote stuff. And then we're going to do one more problem here. Yeah, that's fine. I don't mind. Like I said, I'm willing to work with the reality that's in front of me. So I don't have any, I have no qualms. Besides, I got plenty of time. So, if things like this happen, at least they're taken into account already before I start. I'm willing to work with you. So, but here's what I'm going to do. Here's what I'm going to do, guys. I'm going to finish off this question here, okay, for the foci and the asymptotes here, and then I'm going to show off the next example here. We won't go through actually graphing it, but we'll go ahead and find out how we can get to the standard form of the hyperbola, and then we'll just end off there, and then that'll give you like that'll give you an extra hour to hopefully go to the test, finish it off, do that sort of thing, and give you that extra time. Okay, so I think if you guys are good with that, then, and I want to ask first before I do anything, because my intention was to finish this here and then, just do a little part of the last section. But um, since you guys said that, then that's what we're going to go ahead and do. So just for full disclosure, I think that's okay. See, there's there's teachers that are willing to work with you, and then there's others, and I hope to be willing to work with you. All right, so let's talk about classes on Twitch. Such a good idea? I think so. See, it's better because I don't have to do them on Zoom. Zoom is annoying, right? Zoom is very annoying. I don't want to do corporate meetings, like classes as corporate meetings. No. Gotta be real about it. Let's look at the foci here. So the foci is again c, oops, that should be not c squared. That should just be c. C is equal to a squared plus b squared. Or actually, is it c squared? Let me check one more time. Just need to check that real fast. Oh, it is c squared. Okay. That's fine. All right. No, that was right. Okay. So here we have c squared is equal to 1 squared plus 3 squared. So here we get 1 plus 9. So c squared is equal to 10. And we just take the square root of both sides. And here we get the square root of 10. All right. So we're going to add and subtract the square root of 10 here, starting from the center. All right, so starting from the center here, all right, is what we got here. So let's go again. Our center here is -3, 4, and with our major axis being the y-axis, we're going to have our foci here being specifically, let's do that here. So our foci here specifically is going to be -3, 4 minus the square root of 10, and -3, 4 plus the square root of 10. All right, so if we put that on, if you plug that in the calculator there, and you said, hey, what's 4 minus the square root of 10? You just kind of, guesstimated a bit about where to put it on the graph since they're doing it by hand. So here we get like 0.83, so -3, 0.83. So the foci here in this case would be, let's see, -3, 0.83 or 0.84, so somewhere right about here-ish would be one of the foci here in green. And then the other one's 4 plus the square root of 10. And then again, what's the decimal equivalent for that? 7.16. Okay, again, I'm not looking, obviously perfection's not really being asked here on a handmade graph. So 1, 2, 3, 4, 5, 6, 7. So what it'd be like right here-ish. So these 2 points here in green are the foci here for this graph. Now, the last part is that what you want to find here are the asymptotes for this particular graph here. The asymptotes there are in pink. All right. Now, one of the things that is important regarding the asymptotes here is for the asymptotes, you have to know the formula for this, okay? So if you have this, again, go back to the previous video here. I wrote down the formulas for both, okay? And I'm just going to be referencing it here in this particular instance because you do need the formula here for, if it does ask you on the homework here, it says, hey, what are the asymptotes for this hyperbola? Okay, well, the asymptotes here follow suit in finding this. Let's go ahead and write it down here one more time. So the formula for this one, because y is our major axis here, is going to be, oops, you know what? Pink is kind of light for this one. I do need a darker color. Purple for this. So we have y minus k is equal to plus or minus a over b times x minus h. This is for y y major axis. Okay. So for a y major axis, this is what we have here. All right, so with h and k already defined here, remember h and k here are this is the center here specifically. So we're just going to start off with this. Okay, so let me zoom out here for a second so I can make a little more space. Oh, there we go. Okay, so what we're going to have here is we're going to have y minus k, which is 4, equals, I'm just going to plug that in, a over b. A is 1, so we have positive 1/3 times x minus h, and h is minus 3. And we're just going to solve for y in this case. So let's go ahead and give that a go. We've got need a little bit more space to the right. So this is going to be y minus 4 equals 1/3 times x plus 3. Now the same thing also applies here, by the way. You have a second equation here. Remember, you have two asymptotes. This one here involves negative 1/3 as opposed to positive 1/3. So here we get y minus 4 is equal to negative 1/3 over x plus 3. Remember, these are two different equations that we're going to get here with two different slopes. So here in this case, let's go ahead and put this up here now. Not running out of space here. So y minus 4 is equal to 1/3 x plus 1. Add the 4 to both sides. And so here our first equation here is going to be y is equal to 1/3 x plus 5. All right. And then the next one here, we're going to do this one here next. Again, we get y minus 4 is equal to negative 1/3 x minus 1. Again, with multiplying by positive 3, minus 1. Add 4 to both sides. And so here we get our final equation here of y is equal to negative 1/3 x plus 3. So these are the two equations of our asymptotes that we have here for this particular hyperbola. All right. Any questions? Any questions about that? No? Okay. Hopefully that isn't too bad. Again, it's just following the steps that we discussed here last time. Okay, so the steps here, and I know that it could be, it feels overwhelming, but that's why I break it down into individual steps. So that's way it's easy to see where you're plotting along each time down. You're just taking one piece of information here, one piece of information there, and using those properties and putting it together. All right. Okay. So that is the second example I kind of want to show off here in this case. We do have one more example to do, but as I mentioned here before, we want to just talk about how to get to our standard form here, because now that we've seen a couple of examples here about how to do the hyperbolas, we have a pretty good grasp about how to work with it depending which way that it's written in terms of our major axis. Now, having said that, let's go ahead and put down our next example. So I'm going to get rid of all of this. All right. And we're going to take a look at our last example here. All right, let's try that one. Okay, so this is what we have here for our problem. Okay, all right, so we have 4x squared minus 9y squared minus 16x plus 54y minus 101 is equal to 0. Again, what's our goal here? Our goal here is to put it into our standard form for a hyperbola. So we know what it should look like. What we do need to make sure is how we get there. And of course, as I mentioned here before last time, but let's talk about the key here. The key here is basically the same thing that we did for ellipses. We're going to be completing the square. We're going to complete, actually, I'll just write complete the square twice. Okay, so if you remember how we did it in ellipses, we're going to do the same exact steps here that we did for ellipses. We're going to do the same exact steps here in this instance as well. Okay, now we'll just need to be a little bit more careful. So we'll see what some of those little extra bits that we need to be careful about. We'll see where they factor in. Okay, in any case, let's go ahead and take a look here what we'll need to do first. Okay, first, we're going to group all the x values together. We'll group the y guys together. And then we're going to go ahead and put the 101 here. We're going to move that to the right-hand side. So we're going to add by 101 here, move it to the right-hand side. We're going to keep the numbers separate from the letters. So that's all we're going to do here. And then we're going to group these letters together. So let's do that too. So 4x squared minus 16x. Oh, okay. Well, this one, yeah, double completing the square is certainly possible here when you do hyperbolas or ellipses. The one thing that you have to be careful about actually is I'm glad you're covering this in your class there, Aiken, because you have to be very, very careful about what will be happening here momentarily. So there's a couple of things to keep in mind that you need to be very aware of, especially with sign changes and uh, numbers that we're going to be adding on to the other side here. So there's going to be a lot going on in this particular problem, but you'll see what I'm going to be doing here next. All right, so I want you to see here we have 4x squared minus 16x here, and we have the minus 9y squared. Now notice this says minus 9y squared. Now this is actually important because if we wanted to put in the standard equation of a hyperbola, we need to have a minus in the middle. So that minus is going to go right there. And we're going to kind of group the 9s. We're going to have 9y here, 9y squared. And very important here, you notice I put parentheses around the 4x squared minus 16x squared. Now, I am going to put parentheses around the y. However, this is basically saying minus would be distributed to both. So it's like, imagine, if you will, you actually took out a minus 1. From both terms. So I'm going to put minus 9y squared minus 54y here. And that equals 101. So as you see here, already we start to see sign changes. Again, if I want to group those y's together, I had to change the sign of the positive 54y to minus 54y in order to ensure I have this minus sign here in the middle. So be very careful about that part there. So let me put that in here. Note. Okay. So just want to point that out here because of how important that actually is to the rest of the problem. All right, let's look at what we need to do next here. Now we're not quite out of the woods yet. Okay, we still got a little bit more to go. So next we're going to actually factor out, next is the important part here. If we're going to do completing the square twice, before we even remotely even think about completing the square, we have to factor out the leading coefficient, the leading number here in front of x squared and y squared. It doesn't matter what numbers these are. You have to factor out each of those numbers. Okay, this could be as ugly as possible, and you still have to factor it out. So whatever number's in front of x squared has to come out, and whatever number in front of y squared, it has to come out. We want a 1 in front of x squared. We want a 1 in front of y squared. That absolutely has to happen here. So we're going to have 4. We have x squared minus 4x after factoring out a 4 there. We have the minus sign here. We're going to factor out a 9. And so here we have y squared. And then if we factor out a 9, we have, let's see what we have here. We have 6. So we have minus 6y here, which equals 101. There we go. Please no. Well, this is what happens. I was gonna warn you. This is what's gonna happen, but that's why I'm just focusing on this. The rest of it's doing the hyperbola stuff. But as you know, completing the square is its own little animal. Okay, let's not lie to ourselves. Okay, let's focus on the next part here. Gurney, you're gonna hate my guts, man. All right, you haven't hated my guts already. Let me propose I get you there faster. All right, the next part here is we have to go ahead and take our b term here underneath. We're going to take the minus 4 and minus 6. So we're going to take minus 4. We'll divide that by 2, and we're going to square it. So this is equal to negative 2 quantity squared, which equals 4. We'll do the same thing with minus 6. And let me put that in a different color. Put that in So here we get negative 3 quantity squared, and that's going to equal 9. All right, perfect. So this is what we have here so far. Okay? All right. So now what we're going to do next is we're going to do what the completing the square part does tell us to do. We're going to go ahead and add 4 here on the inside of these parentheses, or for inside with the x guys. And then I'll put this in orange here. We're going to add 9 here. We're going to add 9 here to the y guys here, because that's where we got that one from. Okay. Now, this is also a key point here in completing the square. Let's not forget about this part here. This next part here, this is still within this same step here, but let's remember something here very vitally important if you're going to complete the square twice. All right, one of the big keys is to properly quote unquote compensate the same amount on the right hand side of the equation. Okay, this is going to be pretty key here. You have to properly compensate the same amount on the right hand side of the equation. So let's take a good look here. This will be a good reminder about what we did here from the first section in this chapter, the previous one. So notice I added 4 here. Let's look at this straight up here. We added 4 here. But remember, if I need to balance stuff out, normally underneath completing the square, if I add 4 to one side, I would add 4 to the other side. However, that is not what happened here. We did not actually just add 4. Okay? That works for basic problems, but not necessarily all problems. So how much did we actually add here if we have a plus 4 there on the inside of the parentheses? How much did we actually add here in this case? Yeah, that's correct, Gerda. 16 is exactly correct. Very nice. All right, so we're going to properly compensate here about plus 16. Again, where do we get that from? Well, let's not forget. One of the most important things is this factor of 4 that's sitting right out here on the outside. So in fact, when you did a plus 4 here, you actually do 4 times 4, and that's going to be 16. That's why we have to add by 16 on this side here, because in fact, when you factored out that 4 right from the beginning, you got to multiply that new thing, that new number you put in here, by what you factored out from way back when. So, whatever number this is, you're going to take that number, multiply it by that new number you plopped in, and then that's actually how much you actually added to that left-hand side. All right, let's do it in the same vein for the y's. Well, how about for the y? We have minus 9 here, and we have 9 here. So how much effectively should we add here to the other side? That's close, planet. Be very careful. Note the sign there. It's just not 81, but look for what its counterpart there. Yeah, minus 81, right? Negative. Yes, negative. So that negative, as you see there, it plays a pretty big role, right? That plays a very big role here, because it says, hey, I didn't just take out 9. I actually have minus 9. This ensures that we have the minus sign in the middle there when we get down to our final hyperbola equation. That's what we're aiming for here. So I'm going to put minus 81 here on the right-hand side. That's effectively what we went ahead and added on the, again, we're playing a zero-sum game when it comes to completing the square. So if I subtract 81 on one side, I got to subtract 81 on the other side. That's how we're going to play the game. So let's take stock in what we got. All right. So I'm just going to write down, I'm going to write this down here once again. Okay. Zoom out here for a second. I'll expand the canvas here a bit. Okay. All right. So let's take a gander here at what we have. So I'm just going to rewrite this because there's a lot of messy writing here so far. So we have 4 times the quantity x squared minus 4x plus 4 minus 9 times the quantity y squared minus 6y plus 9. And now let's go ahead and add up all those numbers on the right-hand side. So we got 101 plus 16 minus 81. And so here on the right-hand side, we get straight up 36. Okay. We're very close to being done. We just have 2 more things we need to do. Okay. Let's not forget the next thing that we want to do here is we want to factor both of these guys. We want to factor the x squared minus 4x plus 4, and we want to factor the y squared minus 6y plus 9. All right. So, can anybody tell me here? And we'll put the 4 out here and everything like that. But what does this factor to? What does x squared minus 4x plus 4? What does that factor to? Again, if you're not sure, just say you're not sure. That's fine. There's a particular reason why I asked the question in this manner, but if you're not sure, go ahead and just type in you're not sure. Oh, okay, x minus 2 quantity squared. All right, that is correct. Now you're probably saying, hang on a second. How do I know that? How do I know it's x minus 2 quantity squared? And I totally agree with you, Planet. That is absolutely 100% true. However, I know what this automatically factors to because it automatically factors to, let's write this down as our note here. I've said this before, but again, this is I'm gonna stress this here again as well because this always happens with completing the square problems. Every single completing the square problem is going to work out the same way when it comes to the factoring part here. So let's put note. Uh, it will always factor to x minus b over 2 quantity squared. That's what it'll always factor to. That never changes. So I want you to take a look here. Okay. Notice that I did this deliberately, by the way. So Aiken, if you're still there, I do this part here deliberately with the parentheses. You notice this says minus 2 right here? This minus 2 is put in here intentionally because that I know is the same minus 2 that it will factor to at the end of the day. Same exact one. I don't care how ugly it looks, because of completing the square, that is always going to happen. 100%. It's designed to be that way. If I look at the other side, then the other side is going to work very similarly. Here, I just take this minus 3, and that's what it's going to come down to. I'm going to take that minus 3, go bibbity boppity boop, it goes right there. Congratulations, minus 3. I don't need to guess. I automatically know. And that's the beauty of the process, is that because I don't have to guess, no matter how terrible it looks, it means I can just shut my brain off at that point and be like, okay, fine, here's what it is. Okay, now let's take a good look here at, so we get 4 x minus 2 quantity squared and minus 9 times y minus 3 quantity squared equals 36. All right, now I just need one more step here in order to finish this problem. What should the final step here be in order for me to get the proper standard equation of a hyperbola? We actually did this at the from the very first example here today. But can anyone tell me what should I do here as my to get it into that standard form for the hyperbola here? What do you guys think? What should I do here? That's fine. You can rewatch the. You can rewatch the. I know there's a lot of moving parts here. One thing is if you I wish I had the uh I had a stream there, Aiken, actually, about when I kind of went over it, kind of when I wrote out the steps here, step by step. So I did that in the first section there where I wrote it out like literally step by step. So that's why I'm kind of referring to here in this case. Divide by something, I agree. Divide by what? What do you want on the right-hand side if I want the standard equation of a hyperbola? What do I want then? I agree. I agree, Planet, but we want to divide by something. What's that something going to be? I'll give you a hint. It's the number on the right-hand side. That's a big hint. So if I divided this by 36, I need to divide by 36, not by 4. I need to divide by the right-hand side here. Remember, take a look back at the first example we did here today. When we looked at the first example we did here today, we said if it was equal to 9, we divided everything by 9 because we wanted the right side of the equation there to be equal to 1, to be in the standard equation of a hyperbola here. So here, at this step, okay, it's the same thing as if this happens, and so again, note here, divide everything by the number on the right-hand side at this step. Okay. So that's what we're going to do here as the final step, is we're going to divide everything by 36. I'm pretty sure your right and left hands are pretty easy to figure out. I know there's a lot of moving parts, but I want to reference back to um, what we talked about when we talked about ellipses. And completing the square I know is a bit of a task. So one thing I do like about me kind of going through this is that you have a chance to replay this same example here again, and you can see if you can pick up on those steps there. 4 over 36 there is 9. So we get x minus 2 quantity squared over 9 minus 9 over 36, 4. So we get y, and that's equal to 1. All right, and now we have it in the standard equation of a hyperbola here in this case. Remember, all we're looking for here, the standard equations, as I pointed out here before, x minus h squared over a squared minus y minus k squared over b squared equals 1, or reverse it around. You want it in one of these two forms here. So okay, so that's what I was working for. I wanted that right-hand side to be equal to 1, so that's why I wanted to divide everything by 36. And now this is what I got. And then you could proceed with the rest of the problem from there. All right? I hope that made some sense there. Does anybody have any questions about that? at least need to state that first. Does anybody have any questions? Feel free to ask me whatever. So, all right. Okay. Well, very good then. No problem. Okay. So, if there are no more questions there, Planet or Anna, all right, or Sophros, we're gonna end off here for today. All right. And we will. I want to thank you all again for coming out here to the stream. I know today's stream was rather short, but we're going to come back here on Tuesday, and we're going to start finishing off the last section here in the textbook here, section 7.3. We're going to have a lot to discuss here. Yeah, Planet, you have a wonderful weekend. Have a wonderful rest of your week. We're going to actually have a lot to discuss here next week in regards to the final exam and all that jazz. Okay, so just getting that stuff squared away. Again, we did talk a lot about last time there, but just to kind of finalize everything once again, just to serve as a note there for you, Planet. I was going to say this to everybody here, but just you'll get this info a little earlier. Um, and Anna. You both of you. Um, again, I did take out 3 questions that were from chapter 8. So again, there's like 29 questions there on the final exam. All right, so it will only cover up to section 7.3. All right, so that's it. There should be no questions from chapter 8 on this final exam, and of course, the final exam there, you'll get a bunch of retries and time and stuff like that. So it should be good there. All right. All right, guys. Thank you so much for coming on out here today. All right. Love you all. All right. I will see you all next week. All right. No, look, the transparency is important. Like, you guys have to be kept in the loop. If I just tell you something and there's no context behind it, then it doesn't make any sense. So I don't know why people don't do that more often. You need to put context behind it, otherwise, it's not going to make nothing that anybody does without reasoning is not going to make any sense. And it's just like, well, you're kind of up a creek without a paddle at that point. That's one thing about my own classes. Like when I was taking undergrad classes, I really disliked because I had several people, several teachers who just told nothing. They just told us nothing, and it's just like you have it in a syllabus and it really doesn't say anything at all. So it's like, well, what does that do? It doesn't do anything. It just basically effectively does nothing. So thanks for saying nothing, and thanks for basically not keeping me in the loop of what my expectations are going to be. So the transparency is like super important to me because of that fact. Is because I've felt that way in several classes a long time ago, and I got really frustrated because of that. So I'm like, I better give you reasoning about why I'm doing the things that I'm doing. So because if I don't, then really I think it's just like, you know, I think a lot of people feel that, I'm out to get them, or I'm intentionally making things harder. It's like, no, I promise you there's a reasoning behind everything. So um yeah, I don't want to be that guy. That guy that guy is the guy who got super frustrated when he was a student, and that's not a feeling that I would want to pass on to you either. So, um, all right, guys. Thank you again very much. And everybody stay safe, stay sane, and stay healthy. Somewhere in that order. All right. All right. All right, everybody, take care of yourselves, and we will see you all later. Okay. Have a wonderful day. All right. Take care. All right. See you later. All right, everybody.